Hey guys, we are on 0.3. This is the last pre-section, so the last 0 section. Now remember, on Unit 0, you're not going to have a test over all of it, but this will be the only unit that's like that. Every other unit, when you get done with the last section, you'll still have a mastery check on the section, but then you'll have a unit test over all of them, except for this unit. Okay, because these are skills that hopefully you already have, but if you don't, that's why we're doing this. So today we are graphing linear equations, and we're looking at them only in slope-intercept form. Well, what is slope-intercept form? Hopefully you remember this from last year, maybe Mr. Miller's class. Y equals mx plus b. Okay, so you definitely want that written nice, real big on your paper. That is so important. We will use this all of the time, and not just in this class, but as you go forward in high school math, it's going to keep coming up. Y equals mx plus b. Well, what do these things stand for? Well, your m is your slope. Slope is the rate of change. It's the amount that a line is changing vertically over how much it's changing horizontally. Okay, so slope is also called the rate of change because it's the change between two different things. The vertical change over the horizontal change. And we know vertical, when we're talking about a coordinate plane like these, the vertical change is your y value, your horizontal change is your x value. So you always have to count, here's the last one, rise over run. And that's a lot of times what I hear students say, rise over run, rise over run. The b is your y-intercept. It's where your line crosses your y-axis. And then when you're writing the equation, x and y are going to stay x and y. So those are not changing. Those are x and y's. Okay? All right, let's graph. First one, y equals 1/3 x minus 4. So we know 1/3 is our slope because that's where the m is. And our y-intercept, be careful, it's not 4, it's -4. So you always need to include the sign in front of a number with the number. The first number to plot, even though it's second in the equation, is the y-intercept. So on your coordinate plane, remember this is your x-axis, and this vertical line's your y-axis. Find -4. So here's your origin. There's 0, 0, and you're going to go down 4. Down because it's a negative. Plot a point right on that. Okay, so when you're graphing a line, your first point should always be on the y-axis. First point always on the y-axis. Then from that point, you're going to count your slope. Now remember, your slope is rise over run. So according to this, I need to rise 1 unit and then run 3. Okay, so those are both positive. What direction is positive on the y-axis? Going up. And what direction is positive on the x-axis? Left or right? Right. Okay, so this is the negative, this is the negative. So I'm going up 1. I'm not going to put a point yet. I'm just hovering my pencil there. And then right 3. 1, 2, 3. That's where the point goes. Okay, so again, I went up 1, right 3. Don't say over, because over could be either way. So be specific, either left or right. How many points are on a line? Well, the number of points on a line is infinite, but you only need 2 points to draw a line. However, if you wanted to add more, you could just continue counting that slope out. Up 1 over 3. Up 1 over 3. And then you just want to do your very best to draw a line through those points. Of course, you can use a ruler, makes it a little neater, but you don't have to. Put arrows on the end, and do make sure you extend your line. Don't just make it like a tiny little, sometimes what I'll have students do is they just do this, like just connect the dots. We're not playing connect the dots, we're drawing a line, so make it long. All right, the second one. Now, if you notice on your paper, it's not there. It's not there on purpose. It's because I want you watching the video and paying attention. But you need to write it down. Okay, so write that problem down. You want to have it there, so it's an example for you to look back on. So once you have the problem written down, let's graph it. Again, when you're graphing, you want to start by graphing the y-intercept. In this case, it is 1. Your y-intercept is 1, that's your b. So from your origin on your y-axis, go up 1 unit, plot a point. Your slope is 3 over 5. Again, those are both positive numbers, so you're going to rise 3 and run 5. When you do that, be careful that you do it from the first point you plotted. Sometimes students want to go back to the origin. That's not where you want to go. Go from the first point you plotted. Up 1, 2, 3, and then I'm running positive 5, which means I'm going to go right 5. And put a point. Okay, those are the only 2 points you have to have on your graph to draw the line. You could choose to put more on there, but you don't have to. Okay, if you really wanted to put more points on, if you notice on this graph, 1, 2, 3, 1, 2, 3, 4, 5, I'm off my graph. That's okay, you could still stick it out there, but the other thing you can do is go in the opposite direction. So normally we read this as positive 3 over positive 5, rise over run. But that would be equivalent to negative 3 over negative 5, because 2 negatives would become a positive as well. So you can go in the opposite direction, which if you go from right to left, you'd be going down 3, left 5. So you could do that same thing here, down 3, left 5, and notice that that falls directly in line with all your other points. So that's an option if you want to take it to go the opposite direction. Not perfect on my line there, but that's okay. Make sure you put arrows at the end. All right, 2 more. Oops. Okay, 2x minus 3. This one is a little different because this is not a fraction. But we know our y-intercept is negative 3. And typically y-intercepts aren't fractions. They can be, but it's nicer when they're not because then you can be directly on a line. Whereas with the slopes, that's just how much you're rising and running, so fractions are nice. So fractions are not nice for y-intercepts, but they're nice for slopes. Negative 3 on your y-axis, down 1, 2, 3 from your origin, right on your y-axis. And then, okay, we got to deal with the slope. We need this to be a fraction. 2 can always, any number can always be written as a fraction. What do you put it over? Hopefully you're saying 1. Because 2 divided by 1 is still 2. Those two things are equal. So anytime you don't have a fraction, just stick a 1 underneath it. So your rise is 2. Your run is a positive 1, so we go to the right. Now, if you hadn't put that 1 there, you would have a line that looks like this. You'd go straight up and down. And while that's possible to have, it would not be correct for this equation. So you need to make sure you always remember that there is a run of 1 if you don't have a fraction. Okay, one more together here. We've got 2 negatives here, so let's take one thing at a time. Your y-intercept is negative 1. So from our origin, that just means we drop down 1 unit. And then your slope is negative 1/2. Okay, here's some things to think about. If I have negative 1/2, that negative sign is right out front. You have to choose to either apply it to the top only, apply it to the bottom only. You have to choose one of these. What you cannot do, what it is not equal to, not equal sign, is negative 1 over negative 2. Because this would be equal to positive 1/2. Notice these 3 are all negative. These 2 are positive. Okay, so you cannot put it on both spots. I always choose this one. Okay, apply that negative sign to the rise, to the top number. So from our first point, I would go down 1, but then notice the 2 is positive, so I still go right. Down 1, right 2. Down 1, right 2. Now let's say, okay, suppose we chose this one. From our green dot, our rise is positive, up 1, but now our run is negative, so we would have to go left 2. Do you see how that still lines up perfectly? So you can make the choice which way you're going to do it. Again, I would suggest you always do this way, and always, whatever you choose though, do the exact same thing every time so you don't get confused. But if you would have tried to do this one from that original green dot, down 1 because it's -1, and left 2 would put me here. Clearly that is not in line with the other one, so that is not the right choice. Don't do that. Oh, totally missing my line there. Oh my gosh, that was terrible. Sometimes it's hard to draw on here. But the advantage is I can fix it. Okay, here's 2 more. Again, they're not on your paper. Make sure you write them down. Pause the video and you guys try them. Pause the video now. Okay, hopefully you've paused the video and tried it on your own. If you haven't, rewind and do it. Do what you are supposed to be doing the correct way. Practice with purpose and intention. All right, first one. Y-intercept is 2, and then hopefully you remember this negative sign. Okay, so that means go down 4, and then the 3 stays positive, right 3. Easy, quick visual check is take a look when you're all done. If your slope is negative, make sure your line looks like it has a negative slope. So if you have positive slopes, your line should be going up from left to right. If you have negative slopes, your line should be going down from left to right. Okay, so just a quick visual check to make sure you've got your slope doing the right thing. The second one was a little tricky. Did I trick you? Notice those are not in the right order. We're talking y equals mx plus b. The slope has to have an x with it. It's not just the first thing. These are out of order. Okay, so the first thing I did was I rewrote it in the correct order. Y equals mx plus b. Okay, hopefully that makes sense to you. If not, write yourself a note. Come ask me a question about that tomorrow. And then we need our slope to be a fraction, so I stuck it over 1, plotted my y-intercept of 3, and then went down 4, right 1. Okay, check your answers out. All right, there's a couple special slopes we need to talk about, and the first one is when your slope is 0. Okay, so if you've got a slope of 0, your m is 0, and then you're just going to have some b. So look at what happens. Well, 0 times x is just 0. 0 plus b is just b. Excuse me. So your equation is just going to be y equals a number. Let's do an example. Y equals 4. Well, if y equals 4, how would that line look? What would that line look like? Well, where does y equal 4? It equals 4 right here. Where else does it equal 4? Sometimes students will say, oh, this is a vertical line. Well, if I draw a vertical line in right here, don't do this because it's not right. But if I draw a vertical line in here, is this point, does it have a y value of 4? How about this one? Well, no, that's a 2. This one down here would be a -2. So that can't be y equals 4 because I've got y values that are a whole bunch of other things other than 4. But what if I draw a line this way? What's the y value on here, on this point? 4, 4, 4, 4. The x values are all different, but the y's are all 4. So anytime you have y equals a number, it is a horizontal line going through whatever the number is for your y value. The other one is when your slope is undefined. Okay, and this has a tricky equation that looks like x equals some number. I'm going to call it a because it's not your y-intercept. It's also not your slope. Your slope is undefined. How do you get an undefined slope? That's from a vertical line. Okay, so let's say this time it's x equals 4. Well, where are the x values all 4? Well, I know where the first x value would be 4. Right here. And then, okay, do I want to make them a horizontal line? Well, no, because then I would have x values that are 5, 6, 7, 8, or 3, 2, 1. But if I went vertically, oh my gosh, pretend that's going through here. Then all of those x values everywhere on that line, those are all x values of 4. Every single last one of them. Okay? The reason it's undefined if I choose 2 points and count the rise and run, from this point to that point, I have a rise of 2, but what's my run? It didn't move over at all, so that's 0. Well, you're not allowed to divide by 0. So 2 divided by 0, if you stuck that in your calculator, it'd tell you undefined. That's why we call this slope undefined. Whereas on this one, if I counted the slope between these two, my rise would be none. My rise is not going anywhere. And my run is 3. Well, 0 divided by 3 is 0, hence the 0 slope. Okay? So if you forget, oh, I forget which one's horizontal, which one's vertical, draw the line out, count the slope, and see. You can figure that out. All right, write the equation line. So we're going backwards now. They've given us the line. We need to write the equation. I'm going to do the first one with you. So we know we need it. Y equals mx plus b. That's our main form all the time. The easiest thing to find, even though it's last, is the b. Same as how when we sketch them out, we start with it. When you write the equation, y is always going to stay y. That's not changing. X is always going to stay x. That's not changing. But find your b. So where does this red line cross your y-axis? Well, I'm seeing that happen at 5. So that means I'm going to write plus 5. Don't forget to put a sign here. If it's positive 5, plus. Okay, so I know I've got a point there. Find on your line somewhere else that you have a good point. Like obviously there's points all along the line, including here, but that's not a good spot. I don't know the coordinates there. Here I know the x or the y value, but not the x. So find one where you know both. Ooh, and I see that right here. So between that first point and this good point, count the rise and the run. Well, the rise is 1, 2, 3, but I went down. So that means it has to be a negative 3. Over, what's the run? 1 unit. G unit, just kidding. Y equals negative 3 over 1, x plus 5. And of course, if you wanted to make that negative 3 just by itself without the 1, you can. I would accept either one of those. They're both good. Okay, pause the video. You guys try the next two. Okay, second one should be y equals 3/4 x minus 1. This is a positive slope. Notice my slope is positive. Awesome. And then this one is one of those special slopes. It is undefined vertically. Vertical lines are undefined slope. So that one should be x equals 3. All right, last thing, putting it all together. Here's a story problem. Bob has 3 cakes. He bakes 5 cakes every 2 hours. We need to come up with an equation that represents that. And guess what? We're going to be in y equals mx plus b. Okay? We know y is going to be y and x is going to be x. So b, your y-intercept. It's also, you can think of it as your starting point. So what's he starting with? How many cakes is he starting with? 3 cakes. He is starting with 3 cakes, so there's your plus 3 at the end. Then he's saying he bakes 5 cakes every 2 hours. Well, that's your rate of change. 5 cakes per 2 hours, 5 over 2. Okay, so that would give you, if you did 5 divided by 2, that would give you 2.5, which would be how many cakes he's baking every 1 hour. All right, now we need to fill in a table. Anytime you have time in a problem, that is your x variable, okay, because it is independent. You always put your independent variable on the left side, your dependent variable on the right side. Time doesn't depend on anything. It just moves on its own. What is dependent in this case is the number of cakes that he has baked, that Bob has baked. Okay, so if time is 0, how many cakes has Bob baked? Well, I can see that just from the problem. I don't even need to use my equation, but if you plug 0 in right here, because 0 is your x, y equals 5 halves times 0 plus 3. Well, that would give me what? Just 3, because 5 halves times 0 would be 0, and 0 plus 3 is 3. Okay, you guys calculate the rest of these. Fill out your chart. Pause the video now and do that. Okay, so after 4 hours, and I should have put time in hours, he's baked 13 cakes. After -6 hours, he's bake negative 12 cakes. Now, does this answer, do these numbers even make sense for our story problem? No, they don't. You can't make negative 12 cakes. But it's easy to figure it out because of this equation. Now, the last one's a little different. They didn't give us the x, they gave us the y. So when you go to solve this, don't plug this number in for x, plug it in for y. Okay, it's on the y chart. So here we go, plugged it in for my y, and now this is an equation I have to solve. How do I get x by itself? I'm going to subtract 3. So 20 equals 5/2 x, and then you can divide by 5/2, or you can even multiply by the reciprocal, 2/5. But either way, you get, I'm running out of room here, x equals 8. Okay? And then you can graph. So you know 2 ways to graph. Way back when you used to graph just using a t-chart, you can still do that. But because we have an equation, we can also just graph the equation. So up 3 for your y-intercept, and then your rise over run, your slope, is up 5/2. And then you can plot that, and we are done with this video. Get this packet done, guys.